This video should help you with turning a motion diagram into position versus time, velocity versus time, and acceleration versus time graphs. So here's how we'll look at this and do it. Your first point is always going to be time equals 0 for your position graph, and then the dots just tell you where the position is. So my first dot is going to be at time 0 in a position of 8. So at time 0 in a position of 8, I'm going to put a dot right there. And then my next dot will be at 1, 5. So I'll come over to 1, I'll come over to 1, and I'll go up 5 spots. My next dot will be at 2 seconds, because 0, 1, 2 seconds will be at point 2. At 3 seconds, I'm at -1. Then I'm at -4. Then I'm at -7. Then I'm at -10. So you can see my line right here will go like that. That's my position graph. So it's just your first dot starts at time equals 0. Every dot after that is 1 second. So you're moving over 1 on the x-axis each time. And the position just comes from where it is on the motion diagram. Your velocity comes from the length of the arrow. So we can just do these one at a time. My arrow is going to the left, so it's negative, and it went 1, 2, 3 spots. So my first velocity is -3. So I'm going to put a dot right there. My next velocity, again, went left 3 spots. So at 2, -3. Okay, then again, I went left 3 dots, so it's -3. -3, -3, -3. So I'll put those last 3 dots on, and we can see that our velocity graph will just be horizontal straight across. So anytime that it's constant velocity, it's going to be a horizontal line because it stays the same the whole time, just like these were all -3 meters per second. Your acceleration comes from how much your velocity changes. Well, it went from -3 to -3 to -3 to -3 and so on. It didn't change at all, so that means you have no acceleration. In this one, there is acceleration, so we'll look at this point. Again, we can find our position just by, we know we start at time equals 0, and this point is at -6, because I'm on the negative side and I'm at 6. So at time equals 0, I'm going to put a dot at -6, right down there. And then at time equals 1, I'm at -4. So I'm going to go over to 1 and then down to 4 right here. So that's another dot. Then at 2 seconds, I'm at 0. And at 3 seconds, I'm at 6. So it now it looks pretty much straight, but if this graph was a little bigger or drawn a little more to scale, you'd see this actually comes out a little at the beginning and then starts to curve up and get steeper and steeper. But we'll deal with when graphs are curved and when they are linear in a little bit. You don't need to worry about that right now. For my velocity, I'm going to look at how far they go. So this one went 2, so it's going to be 2 meters per second. And then it went 4, so that's 4 meters per second. And 6, so that's 6 meters per second. Now I'm going towards the positive side, away from the negative side. So this is a positive velocity. So my first velocity is at 2, so I'm going to go over to 1 and put a dot at 2, over to 2, put a dot at 4, go over to 3, put a dot at 6, and that is my velocity graph. So notice that for my position graphs, my first dot was at time equals 0, but for my velocity graphs and for my acceleration graphs, which you'll see in a second, my first dot actually comes at 1, not at 0, because you need more than 1 point to find your velocity or acceleration. Last thing here for the acceleration, we can draw these arrows and compare them. And we see that I went from 2 to 4 to 6. So how the amount of change is going to the right, and it has changed from 2 to 4, which is a value of 2, 4 to 6, which is a value of 2. Or you can just look at it and see how much does it have to change by. +2, +2. So my acceleration is +2 and +2. So I can just draw that as my graph. Horizontal. Your acceleration graph in this class will always be horizontal. It will either just be, is it at 0, or is it as a positive number, or is it at a negative number. But we always deal with constant accelerations, whether it's 0 or a number. You'll never have a diagonal line or a curved line for your acceleration.